Howdy folks, once again it's Donnie, and this time I'm coming at you with a demonstration of how permissions settings work for files on Linux and Unix operating systems. So you see here that I'm in my perm demo directory that I created within my home directory, and I've created a dummy donnyscript.sh file, and you see when I do an ls-l, you see the permission settings come up like this. Now, of course, this leading dash here, we saw in the file types video that means that this is a regular file. And then we have our permission settings here, and they're divided into three different groups. We have this group here, read write, for the user of the file, and then we have read write for the group that's associated with the file, and then we have read for all others. In other words, we have the read permission for anybody who's not the user of the file and who's not a member of this group. And of course here, the user we see is Donnie. Hey, that's me. And we also see that the group association is with the Donnie private group in this case. So let's go over here on our notepad and let's break this down a little bit more. Come over here, we see we have user, group, and others here. And we can also have an executable permission on these files if we so desire. Except that when you create a file, by default, it's just going to have read-write permissions for the user and the group, and read only for others. So when we create a file that we want to make executable, in this case we have a shell script file that needs to be executable, we have to set the executable bit ourselves. So in order to change permissions on a file, we are going to use the chmod utility. And we can just go ahead and do chmod. And let's say that we want to just add the executable permission for the user of the file. We can do u plus x, like so, and then the name of the file afterwards. And by the way, the reason that we say that I am the user of the file instead of the owner of the file is because of this right here. We need to have the U for the user, and then we're going to reserve the O for others. So we can do that, and we can do our ls-l, and we can see now that we have an executable permission bit set. And we can also add the permission to the user and the group and to others all at the same time if we want to. We can just do chmod a plus x, like so. And that will add it for everybody, which you may or may not want to do depending upon the situation. So there we have read, write, execute for the user, read, write, execute for the group, read and execute, but no write for others. We can also perform multiple operations at the same time. And let's go ahead here and take away the execute permission for the group and for others. We can do g minus x, comma, o minus x. And it would help if I were to specify a file. There we go. So there we have it. So we have read, write, and execute for just the user, and then read, write for the group, read only for others. So it's pretty simple so far, right? But we can get a little bit more complex. If we wanted to, we could have like, and we're just going to say that we're back to where we were normally. We could maybe do a u plus x, o minus x, g plus x. I mean, we can have all those combinations like that just to do multiple operations at the same time. But that gets rather unwieldy, okay? So, and by the way, this is called the symbolic method. It's called the symbolic method because we are using the U, G, and O symbols in order to add or take away permissions settings. But that gets really, really unwieldy, as you can see. And also, if you need to write a shell script that is going to be creating files and then setting the proper permissions on those files, you can't really use the symbolic method within the shell scripts either. So we need something a little bit more simpler. I mean, with the symbolic method, the only way that you're going to know what permissions you're going to have after you perform the chmod operation is to know what permission settings you have to begin with. So if you write a shell script then using the symbolic method, you're going to have a lot of code in there to detect what permission settings are set, and then you're going to have the code in there to say, okay, if this permission bit is set, take it away. If this one is not set, add it. And you're just going to have to do that for each and every one of these different permissions. And that's going to get really, really, really tedious trying to write a shell script like that. So we need something a lot simpler. So in order to solve that problem, we're going to use the numeric method of setting permissions. Now the way that works is that each one of these permission settings has a numerical value. The read permission has a value of 4, the write permission has a value of 2, and the execute permission has a value of 1. And then we can do the same thing for the group and same thing for others. So if we have a file with read, write, and execute set all the way across the board, it's going to have a permissions value of 777 because 4 plus 2 plus 1 equals 7. So we just add these up separately for the user, the group, and others, and we come out like that. Now, if we want to take this away, if we want to take away the execute permission here for the user and take away the execute permission for the group, and then take away write and execute for others, which is the default way of creating files, then it's going to be 664. So 4 plus 2 equals 6, 4 plus 2 equals 6, and then just 4 for 664. So then we can use our chmod to set whatever permissions value that we want to set without having to know what the permissions value is ahead of time. So it makes things a lot simpler, and also makes it so that we can use this chmod command within a shell script. The way that works, we just go over here and we will do like 664, and that gets us back to the way we were before. And then if we want to add the execute permission for the user and the group, we can do chmod 774 like so. And if we want to take away permissions for everybody except for the user, that's real easy too. Just do chmod 700. So now we have read, write, and execute for the user of the file, but nobody else can get to it. So that greatly simplifies things. And as I said, it just makes it so that you can use your chmod within a shell script to set whatever permissions value you want on a file. And we can also do the same thing for directories. Let's go ahead and make a directory. So there we have our directory. And you see something curious there. You see that we have execute permission on the directory. And we have that execute permission set for everybody. Everybody can get into that directory. Well, not really, because it's within my home directory, which only I can get into. But if this directory were out in the root of the file system, everybody would be able to get into it because it has execute permissions all the way across the board. And that's what that execute permission does for us on directories. It allows people to CD into it. If we were to take away the execute permission, then we can control who can get into that directory. So for example, we can do chmod 700, like so. And we can see now that only I can CD into this directory. Now, there are two other special permissions settings that we want to look at. One is called SUID, and the other is called SGID. When we have an SUID, what we're going to do is we're going to have an S right here for the executable position of the user. If it's a lowercase s, that also means that there is an underlying executable permission for the user. If we have an uppercase s instead, that means that there is no underlying executable permission for the user. But normally you're going to see that with a lowercase s because your SUID and the executable for the user pretty much go together. We also can do the same thing for the group, and that is called the SGID, where we will have an S right here. Again, if it's lowercase s, there is an underlying executable permission. If it's an uppercase s, there is no underlying executable permission. But again, you will normally see this with a lowercase s with an underlying executable permission. Now, these are settings which you're not going to set yourself. These settings are on files that get installed on the operating system, and they are necessary in order to make the operating system work properly. Now, what the SUID does is it gives whoever accesses that file the same privileges as the user of that file. So we can go over here and we can go into, well, first let's do which p wpass, or pass wd rather, like so. And we see that we have in the USR bin directory the passwd executable file. And we can do ls-l usr bin passwd, like so. And you can see over here it's in pretty red, and that just means that we have the SUID set there. So the passwd utility is the utility that a user can use to set his or her own password. Of course, the root user can use it to set anybody's password, but the root user would need root privileges in order to do that. But a normal user can set his or her own password without root privileges. And what does that for us is that SUID there on that executable file. So this allows any normal user to be able to use that utility, which in turn would change files that normally only the root user would be able to change. And I'm talking about the file that contains the information for user passwords. So if we were to take that SUID permission away, which we're not going to do, but if we were to take it away, then normal users would not be able to change their own passwords. They would have to call the root user anytime they needed to change a password, and that's not a good situation. So that's just one example of the SUID on our operating system files. The SGID, it will work the same way, and you will see some SGID files throughout the system as well. But again, on files, we are not going to set the SUID or the SGID ourselves. But just to show you how it works, the SUID permission has a value of 4,000. And of course, you could use a symbolic method to set the SGID and SUID. To set the SUID, we just do U plus S. And to set the SGID, it would be G plus S. And of course, the file name afterwards, right? But again, we're not normally going to do that on files. Now, setting SGID on directories is an entirely different story, and we'll have a separate video about that later on. To use the numeric method of setting SUID or SGID, we will assign a value of 4,000 to SUID and a value of 2,000 to SGID. In order to set the SUID on a file, we just add 4,000, whatever the normal permission setting will be. And so we can do like 477, for example. Make it executable for everybody. And, of course, the name of the file. And to set SGID, just add 2,000. And then if you want to set them both together, you can just change that to 6,000. So it's going to be 4,000 plus 2,000, and that will make 6,000. That will set both your SUID and the SGID together, okay? But again, you're not going to do this yourself on files. If you do, you are going to create a big security problem. So just don't be doing this. Okay, don't be doing this on your files. Whatever files are on the system that already have the SUID and SGID set, that's the only ones where you're going to need them. Then the final thing I want to look at is the concept of the umask. And the umask is very, very handy. And first, let's go over here and we'll take a look at the umask here. We just do the umask command, and you see that we have a umask value of 002. Okay, and it's just 002. That leading 0 means that that is an octal format number. So it's just 002. So what's that mean? Well, it means that if we have a umask of 002, it means that we are going to take a value of 2 away. So that means then, in this case, we have, and let's go ahead and put this back here like so. So this means in this case, since we have a value of 2 here for our umask, it's going to take this value of 2 away here for others. So it's going to take away the right permission. Now we can set other umask values if we want to. So let's go into our perm demo directory again here. And this time we're going to set a umask of 077, like so. We'll do umask like that. And that tells us that indeed we have set the new umask. And we can create a file. Like so. We'll do ls-l on that file. And we can see now that we have taken permissions away from everybody except for just me. Now, we're not normally going to do that within our own home directories. We're not going to do that for our own environments. We can make it permanent if you want. There is a configuration file where you can put that in here. But we're not normally going to do that for ourselves because it's kind of pointless. Because on Red Hat style operating systems, which is what I'm using here with the CentOS, the home directories are locked down by default anyway, so that nobody else can get into them. And also, if you are on like a Debian or Ubuntu or Slackware system where home directories are wide open by default, it's just easier to just go ahead and change the permission setting on your home directory to keep everybody else out than it is to set a new umask. It just makes more sense like that, okay? So where the umask really comes in handy is with shell scripts or configuration files. So we can go over here in the etc directory, for example, and we can take a look at a file called login.defs. And this file is going to contain some of the default settings for when we create user accounts. So if we go into here, we'll go down to the bottom of this file, and we are going to see down here this line here which says umask 077. So this is the way you will always find it on a Red Hat style operating system, whether it be Red Hat Enterprise, CentOS, or Fedora, or anything else that's built from Red Hat. But what this does for us is it makes it so that when we create a user account, the home directory for that new user will automatically be locked down so that nobody except for the user of that directory can get into it. So just to show you, we'll go into the home like so, and you can see here that with the exception of this directory right here, which I created myself, that's not actually a user. That's something we'll talk about later when we talk about putting the SGID on directories. But for all of the normal users that I've created, you see that they're all locked down so that only the user of those directories can get into them. And so we'll talk more about creating users and groups and all that kind of good stuff in a future video. Then after we talk about creating users, then we'll talk about this right here about setting the SGID on our group directories, okay? So that's going to be a topic for a future video. Another thing I should point out is that when you set a umask, it does not affect the permission settings of any of the files that you've already created. So you see here, I've closed down my window and opened it back up again so that we can go back to the default umask of 002. And then I can just go ahead and create another file. And we see there that the permissions values are 664, just as they should be. So we set our umask of 077 and create another file. We'll create yet another file. And so we see we have our yet another file down here with read-write just for the user. But these other files that have other permission settings, they're still the same. So there's our another file right there, which I just created with the old umask of 002, but it's still the same. So when you set the umask, it's only going to affect files that you create from that point on. It will not change the permissions values of any files that you've already created. So anyway, I hope you enjoyed this video, and I hope you were able to learn something from it. Stay tuned. We are going to have more videos to come. So be sure to like and subscribe, and that way you will get the latest news, the latest notifications about anything that we add here on our channel. So that's it. Have a great day, and we'll see you in the next video.